equilibrium income determination. So how is the income determined in the economy? That is the equilibrium income. Now, we are going to analyze two markets. We want to look at the goods market first, and then we look at the capital markets or the money markets. Then we will see how the equilibrium income is determined. So first we need to analyze equilibrium in the goods market. Now equilibrium normally occurs when there is no tendency for the variables in the economy to change. Now in the goods market, equilibrium arises or occurs when the planned aggregate expenditure is equal to the aggregate output. So when expenditure equals output, we have what we refer to as equilibrium. Now, in this case, we can assume a simple closed economy. That is an economy that does not have the external sector. So we can use Y to represent the output. So the planned expenditure in the economy, we have the consumption and the savings. So consumption and the savings and investment is what we can categorize as expenditure. So consumption by households. We also have investment by farms and also the government. So this constitutes the aggregate expenditure. So the aggregate expenditure or aggregate output in this case will be represented by Y, which is equal to consumption plus investments. So the consumption plus investments gives us the aggregate expenditure. So the aggregate expenditure should be equal to the aggregate output. So from this simple model, we can be able to see what the equilibrium condition is. Now, if this condition does not hold, then there will be disequilibrium. If the aggregate output is not equal to the aggregate expenditure, then we will have a situation of disequilibrium. So if output is greater than aggregate expenditure, then the output is greater than the planned aggregate expenditure. And there will be unplanned inventories. So farms will be accumulating inventories because the aggregate expenditure is lower than output. And in this case, farms will accumulate inventories in their stores because the demand for them is lower. So if output is less than the aggregate expenditure, there will be unplanned decrease in inventories. In this case, we'll have a shortage of inventories in the economy. So this simply means that equilibrium occurs only when planned expenditure equals output. That is when we'll have the equilibrium condition in the economy. Now, if we have, suppose we have this simple investment and output functions. So we have the consumption function given as 10 plus 0.8y, and then we have investment which is fixed at 500. So how can we get the equilibrium income? So we can compute the equilibrium income, and in this case, so the income is simply given by C. So it will simply be given by C so it's given by C plus I plus investment. So we can compute Y. So Y will be given by, so this will be given by 10 plus 0.8 Y plus 500. So you need to take the like terms together. So this is Y plus 0.8 Y so this would be equal to 500. So this 0.2 which should be equal to 500. You can see that. Then sorry, it's 510. Now we can find the value of Y in this case. So the value of Y will simply be, so we have 0. So we have so we have 0.2Y. So the 0.2Y would be equal to 500. Sorry, my pen is misbehaving. So this 0.2Y which should be equal to 500. So your Y should be equal to 500 divided by what? So you divide by 0.2. So that should be equal to 2,250. Sorry, 2,500. That's a simple calculation that you can do. So oh sorry, it should be 510. It's 510. So the 510 you need to add it. You need to add 10. So this one should be equal to 510. So this one should be equal to 2,500 and what? 50. So 2550 should be the answer. So that's is how you compute the equilibrium income. So the answer should be 2550. So that is how you get the equilibrium income from that simple illustration. Now we can also look at the savings investment condition. Now the savings investment condition, now this is the condition foods market. Savings would be equal to investments. So if we assume that the economy does not involve any foreign trade, and we are using the income approach to compute the national income, then the income will be determined by consumption plus savings plus taxes. So that is using the national income approach. So we can also use the expenditure approach, which means that under the expenditure approach, the income is given as consumption plus government expenditure plus investment. So this gives you the aggregate expenditure approach. So Y is the national income, C is consumption, S is savings, T is the tax, G is the government expenditure, and I is the investment. Now we can equate this, that is income to expenditure, because we said that equilibrium in the goods market requires that aggregate output should be equal to the aggregate expenditure. So we have the aggregate expenditure and we have the aggregate output. So we can equate the aggregate output, aggregate expenditure. If you equate that, is what you get, and you can cancel out the terms that appear on both sides. So you have the savings plus tax should be equal to the government expenditure plus investment. Now, assuming that the government expenditure is equal to the taxes, because the government consumes what it collects in the form of what? Taxes. So if we assume that G is equal to T, then equilibrium in the goods market is achieved when investment is equal to the savings. So this is the equilibrium condition in the goods market, which simply means that the economy should be at equilibrium at any point along the investment savings line. So in simple terms, equilibrium is achieved in the goods market when investment equals savings in the economy. So we have the investment savings function. So we have the aggregate expenditure on the vertical axis, or the aggregate demand, and we also have income on the other side. So the investment is upward sloping. So which simply means that investment sorry, the previous slides, okay. This is the previous slide where I have said investment, savings investment condition for the goods market. So this is the national income approach to computing GDP. We also have the expenditure approach. Now, since they give the same value, you can equate this So once you equate this, cancel the like terms, you get S plus T should be equal to G plus I. And then we have said that assume the government expenditure is equal to that are collected. In this case, investment should be equal to savings. And this is the equilibrium condition in the goods market. So that is the graph for the savings, which is equal to investment function. So it is upward sloping, which implies that as the aggregate demand increases, the investment versus savings also increases. Now, at equilibrium, all variables are fixed. So we have, this is the equilibrium point where this aggregate demand function cuts the IS curve. At this point here, so we have Y star, and at this point, consumption, investments, and the government expenditure are fixed. Now, this gives you the equilibrium output, that is income, and we have aggregate expenditure on the other side. So the aggregate expenditure, we have said, is made up of consumption, investment, and the government expenditure. So at this line here, this one, they are fixed. Now, that diagram simply shows the equilibrium condition. So at Y2, there is excess supply, and hence disequilibrium exists in the economy. So at Y2, we have excess supply, and disequilibrium exists. At Y1, demand is greater than supply, so we have a disequilibrium situation again. Now, these situations of disequilibrium are normally short-lived because there is a tendency for income to move towards Y star. Now, if the consumption is a function of income and the investment is constant, then equilibrium can be shown as follows. So if investment is constant and consumption is a function of income, then this is how we can obtain the equilibrium condition. So the Y star is the equilibrium income. That is where the desired savings equals to the desired investment. So if Y is less than Y star, then the desired savings are less than investment. At any income below Y star, you can see the IS curve is below the aggregate expenditure curve, this one here. It is below, which means the desired savings are less than the desired investment. So whenever we have Y, which is greater than Y star, then the savings are more than the desired investment. So this part here simply shows the region where the savings are more than the investment, or are greater than the investment. Now, when savings is equal to investment, the addition to demand due to increase in investment is equal to the subtraction from demand due to less spending by the households. So if we know that the aggregate demand is given by C plus I plus G. So C is the consumption by households, I is the investment by firms, and then we have government consumption, which is G. So if both the government expenditure and the investment are given, well, they are constant, then the aggregate demand will be due to changes in consumption. So if G and I are a constant, then any change in income will be as a result of consumption. So we can have an illustration of a simple economy, a simple closed economy with different levels of aggregate expenditure. So you can see we have different levels of expenditure. So we have investments, which is fixed. So we have consumption, which is a function of income. So we have, so if you add investment to the consumption, so the consumption curve will simply shift upwards. And when you add the government expenditure, so it will continue shifting upwards. So this diagram simply shows that equilibrium income increases with every addition of injections into the economy. So the injections is in form of investment and government expenditure. So you can see when we have consumption, that is household consumption, this is the equilibrium income. So if we add another variable, which is consumption by farms, so the consumption by farms is represented by I, which is investment by farms. So you see the equilibrium income moves from Y0 to Y1, and this line, which is the aggregate expenditure function, shifts upwards. So if you add the government expenditure, it will also shift to another level. So we have these equilibrium levels, which represents different levels of income. That is the investment savings. Now, let's see how we can derive the IS equation, that is the investment savings equation, and the curve. So we have seen that equilibrium in the goods market requires that savings equals what? Investment. And the other factors that causes changes in consumption, savings, and investments will therefore influence the equilibrium position. So suppose the investment, the consumption and investment function are given as follows. So this is the consumption function, which is made up of autonomous consumption plus induced consumption. We also have the investment function, which is made up of autonomous investment and the induced investment. So the values of beta and k, they are less than, they are between 0 and 1. Because they cannot be more than 1, they are between 0 and 1. Beta is the propensity to consume, the marginal propensity to consume, and the k is simply the marginal propensity to invest. So Y is the income, R is the interest rates. So the K and beta are the parameters which I've already said they are the marginal propensity to consume and marginal propensity to invest. So from this, we can proceed and derive the IS equation. So we know from the expenditure approach that income is given as savings plus investment. Now, since we have our savings function, we also have our investment function. So we can represent our income as a function of savings and investment in this form here. That is alpha plus beta y plus I naught minus kr. So the first two is the consumption, and we also have the investment. So we can realign our variables such that you get y, that is beta y, to the other side. So if you do that, this is what you will get. Then you can factor out y. If you factor out y, you have this equation. Then you can divide 1 minus beta. So if you do the same, you have what? This is what we have. So before you divide both sides by 1 minus beta, what we are interested, we want to make r the function, sorry, the subject. Make r the subject. So if you want to make r the subject, you take this to the other side and subtract both sides by y into 1 minus beta. So if you do that, this is what you'll get. So make r subject. Make r the subject. You simply divide both sides by k. So you'll have this as the IS equation. You'll have this as the IS equation. So remember, when we were discussing about the savings, so we said saving is a function of interest rate. And then we said investment is also a function of the interest rate. Now, this gives us the IS equation we have been discussing, investment and savings equation. Now, using the savings approach of deriving the IS equation, remember that savings is also a function of income. And we said S is a parameter that is between 0 and 1. That is the marginal propensity to save. So we said that at equilibrium, the savings equals investment. That simply means that at equilibrium, the induced savings should be equal to investment. That implies that KR should be equal to I naught minus SY. So you also make this one the subject, make R the subject here. You get the savings for the IS equation as given. So this one is the same as what we have done here. So it is the same. So those are the IS equation, and the IS equation expresses the interest rate as a function of income. You can see we have y here. The other are constants, I naught over k, s over k, those are constants. Just like what we have here. The first part, which is alpha plus I naught over k, is the same as I naught over k. The other part, which is 1 minus alpha over k multiplied by y, is the same as s y over k. So that simply means that the IS equation expresses the interest rate as a function of income. So from this equation, we can note that at the equilibrium in the goods market, the interest rates and incomes are inversely related. So the interest rates and income are inversely related. That is, as the interest rates increases, income reduces, and as the interest rates reduces, the income increases. So that implies that the IS curve is downward sloping. So from here you can see the nature of the relationship between between R and Y. The negative sign here implies an inverse relationship. That means that as R increases, Y reduces. And as R reduces, Y increases. So that gives you a downward sloping IS curve. Now the investment savings function simply shows the relationship between the interest rate and income. That's what the IS shows. The relationship between the interest rate and income. And we have said it's a downward sloping relationship. So that is the graphical derivation of the IS function. This is simply the IS function we are talking about. Now, how do we derive the IS function graphically? Now, the aggregate expenditure function determines the specific national equilibrium income. Now, since we said that the aggregate expenditure equals consumption plus investment, and investment is a function of interest rate, then aggregate expenditure is also a function of interest rate, which implies that different levels of expenditure, that is E1, E2, and E3, will be realized at different interest rates, that is R1, R2, and R3. So that implies that different levels of equilibrium income will also be realized. That is Y0, Y2, and Y3. So to derive the IS curve, then we proceed as follows. We have the aggregate expenditure versus income, and of course, we can derive the IS equation. So we said the IS equation shows the relationship between the interest rate and income. So if we start with the aggregate expenditure and income curve, so when we have the aggregate expenditure 1, that is E1, which we have said it's also a function of what? Interest rates. So when we said this, that when the interest rate is the lowest, sorry, it's highest, when the interest rate is highest, then we have the lowest level of income, which means we start here. This is the highest interest rate, which corresponds to the lowest income. Then we move. When the interest rate falls, the income rises. So we move to the next interest rate, which is the second. Then we said when the interest rate is lowest, the national income is highest. So this is the highest level of national income, which corresponds to the lowest interest rate. So if you join these points, you'll simply get a downward sloping curve. You get a downward sloping curve, which is the IS equation. That is how we derive IS equation. Now the IS curve shows the equilibrium position where the desired expenditure equals to the desired income. It is downward sloping since investment is an inverse function of interest rate. So at higher interest rates, there is lower investment spending, hence lower aggregate income. So from the diagram we have above, the interest rate R1 corresponds to the income level Y1. So you can see the income level Y1. So Y1, in fact, is the lowest level of income, and R1 is the highest interest rates. So that simply shows the relationship. So as interest falls to R2 and then R3, the aggregate expenditure curve shifts to E2 and E3, while income increases to Y2 and then Y3. So you can see what happens when the expenditure curve shifts upwards. So the income level rises and the interest rates goes down. Now the shifts in the IS curve. What can cause a shift in the IS curve? So we said that if income is greater than expenditure, savings will increase and the IS curve will shift outwards. So if income is greater than expenditure, we expect a shift in the IS curve outwards. So if expenditure is less than income, savings will decline and the IS curve will shift inwards. So the change in income and the change in expenditure will lead to a shift in the IS curve. Now, when expenditure equals the income, the goods market is at equilibrium. And in this case, we can define the IS curve as the locus of points corresponding to rates of interest and the levels of income that produce equilibrium in the goods or in the product market. That is how we can define the IS curve. Now, an outward shift of the IS curve would be caused by an increase or a decrease in n of the following investment. So if investment increases, we have an outward shift in the IS curve. Autonomous consumption, if it increases, then the curve shifts outwards. Government expenditure, if it increases, we expect to have a shift of the IS curve outwards, and then net exports will also cause an outward shift in the IS curve. Now, when do we have disequilibrium in the national income? So we have said what, or we have discussed what brings about equilibrium in the national income. So we said disequilibrium occurs when the aggregate expenditure exceeds the aggregate demand, or vice versa. Whenever investment is not equal to savings, we will have a disequilibrium. So if savings is greater than investment, it implies that the aggregate demand is less than output. And if S plus, that is consumption plus savings, is greater than the consumption plus what? Investment. So this simply leads to the accumulation of inventory, forcing firms to reduce production and induce a decline in the national income until the savings equals investment. So if savings are less than investment, it implies that the aggregate demand, which should be equal to savings, so consumption plus investments, are greater than Y. And therefore, consumption plus savings is less than the consumption plus investment. And this means that inventories will be sold and the business will produce more, leading to more supply of goods until savings equals to investment. So the planned investment and the planned savings do not always equal each other. So the changes in employment, production, and income occur, causing the changes in the savings and investment. So the direction of these changes will be towards equality, savings and investment. So the savings will change, or the flexibility in savings and investment will simply ensure equilibrium in the goods market. So if planned investment and planned savings do not change, in the production will force consumers to change their savings plans, or firms to change their investment plans, or both, until investment equals the savings. Now, it is only at equilibrium that both planned and realized investments and the savings will be equal. However, the realized investment and the realized savings are always equal. Now, I think that is all about the equilibrium in the national income. Equilibrium is always equal. Now we need to look at another concept, and this will be more of calculations. So we have discussed the national income, and you know the components of the national income. So the next thing that we look at is the multiplier concept. Now the multiplier concept, what we mean by a multiplier is simply the number by which the national income changes due to a unit change in n of its components. So we have the components of the national income as consumption, investments, the government expenditure, we have taxes, we have net exports. Those are the components of the national income. Now, under the multiplier concept, we will be interested to know how much or by how much the national income changes if we have a unit change in one of the components of the national income. So for example, if we have income which is determined by C plus Y, but we have C as made up of autonomous consumption plus induced consumption. So our national income or our annual income will be determined by this. So you can find the equilibrium national income by factoring out Y here. So our Y will be made up of this, that is equilibrium income. Now under the multiplier concept, suppose that the autonomous investment increases by I plus what? That is change in investment. So the new equilibrium income will be made up of this. So the new equilibrium the previous slide, okay, this is what I've said. Now the multiplier I said is the number by which the national income changes due to a unit change in n of these components. So suppose we have this simple expression where the income is made up of investment plus consumption. But consumption is made up of autonomous consumption plus the induced consumption, which means our income is made up of the consumption part plus the investment part. So from here we can determine the equilibrium income by getting the like terms together. So we make Y the subject. So if we do that, our equilibrium income will be made up of this alpha plus investment over 1 plus beta. So suppose investment increases, so our induced or our new equilibrium will be made up of this. It will be made up of the previous level of income plus the change in what? The income, which is occasioned by the change in investment. So this is what we'll have. So the first part is made up of the previous level of investment, that is Y1. This part is Y1. Then we have the change in investment. So you can get the change in income as the new income minus the previous income, which is given by this part here. So therefore, the change in income will be given by 1 over 1 minus beta times the change in investment. So we can get the change in investment, so the change in income over the change in investment. So the change in income over the change in investment will therefore be just divide both sides by change in investment. So it will give you this. And this is what we refer to as a simple investment multiplier. So this is a simple investment multiplier. And what this tells us, so it simply gives us the amount by which income changes if we have a unit change in investment. So if we change investment by 1 unit, so by how much our national income will change. So this expression is what we refer to as the investment multiplier. So for a closed economy, so the multiplier is very simple as it can be seen. But where we have an open economy, which includes the external sector, then our multiplier would be a bit more detailed. So for example, we have this, we are given the national income as 100. We have the change in investment as 25. And then we have the marginal propensity to consume, which is made up of beta, which is 0.8. So the change in income, we can compute the change in income, which will be given by this expression. So the change in income from the previous part, you can see, it's given as 1 over 1 minus beta is the change in investment. That is what we have here, this part here. So our change in income will be 125. Therefore, our investment multiplier would be given by the change in income over the change in investment, which is 1 over 1 minus beta, which is simply 1 over 1 minus 0.8, which is 1 over 0.2, gives you 5. So our multiplier is simply 5. Change in income over change in investment. 125 over 25, you'll get 5. So this is our investment multiplier.